Fortunately, everybody in this room is not impoverished. And the reason we're not impoverished is because 200 years ago there was an industrial revolution. This talk is how we might spread some of the benefits of that more widely than they are at the moment. Possibilities and potentials, it says, for manufacturing in the home, where home is fairly broadly interpreted. RepRap is a portmanteau word, as we shall see in a moment. What it stands for is Replicating Rapid Prototyper. Rapid Prototyper is polite engineering speak for a three-dimensional printer. It's a machine that prints three-dimensional objects. And there's a picture of it, and indeed it's just printed something. The little white block you can see on the blue base there, and that block is also on the computer screen on the left. And the interesting thing about RepRap is that it's capable of printing a significant fraction of its own bits and pieces. That block is actually a part of itself on the right-hand side in the picture there. So it's a machine that doesn't print all of itself, but it prints quite a bit of itself. Let's look at a few facts. It can copy about half its own parts. And we, very carefully, when we chose the rest of the parts, the other half, made sure that you can buy them in ordinary hardware shops, or occasionally you have to get them online, but they're pretty much universally available all over the world. And the cost of all the bits and pieces to put this machine together is about £300, which is a serious sum of money, but it's not too horrendously expensive. The size of bits and pieces that it can make, 200 by 200 by 140 millimeters. So the machine itself that you just saw in the picture is about so big, sitting in front of you on a desk. The materials it works with, most plastics, that's thermoplastics, plastics that melt and then set again. And the rate at which it prints, not all that fast, about 19 milliliters per hour. And that means that to print all the parts of itself that it can print takes about 2 days at the moment. Perhaps the most important thing about it, apart from the fact that it can copy a significant fraction of itself, is the license under which it's distributed. It's distributed under the new general public license, the GPL. That's the same license that's used for Linux and other free software. And what that means is that all the stuff that you need to make one of these machines is freely available, no charge, to everybody who wants it on the web. You just download it. What can it make? Well, here's a set of examples of objects that the machine makes. I took these just by going to the website that we run called Thingiverse. Thingiverse is a website where anybody can upload a design for anything, and then anybody else can download it and print it in their machine. And top left, somebody's drain in the shower tray, and their shower broke, so they just printed another drain for their shower tray. And they're now taking showers again, fortunately for everybody around them. Staying with the bathroom theme, in the middle on the top, there's a stop for a shower door, not made by the same person, made by somebody else, and that stop was made in the machine. It's got a little piece of cork from a wine bottle in it to just cushion the door as it hits it. Top right, some little drawers for putting things in, maybe electronic components, maybe jewelry, and the drawers stacked together to form a big chest of drawers, if you will. Staying with the jewelry theme, bottom left, some little containers for various pieces of jewelry and rather fancy shapes. In the middle, at the bottom, is a thing that's called a Saris linkage. It's a parallel motion that doesn't involve sliding, and that's actually being developed by people who are interested in increasing that 50% proportion, the proportion of parts of the machine it can print for itself. This is one of the devices that may well allow us to up that percentage. And finally, bottom right, a little robot that runs around. It's an educational toy. RepRap made all the mechanical parts for that. So it's pretty versatile in what it can make. But as I say, one of the key things about it is that it also makes itself. And so anyone with a machine can make another one for their friend. And then their friend can make all of those objects as well. And here's, in fact, a picture of the first machine reproducing. You'll see the machine looks different there to the picture that you saw in the first slide. This is version 1 of the machine, and it's the first time it replicated on the 29th of May 2 years ago. On the left is the parent machine. On the right is the machine that it made. And there's me on the left, and a guy called Vic Oliver who's on the project on the right. And it didn't quite work when we copied it to make a new version of itself. However, and the reason it didn't work, incidentally, is that there's a belt that runs around that drives one of the axes up and down, and we made that too long because we're very stupid. So we found that the machine would work if you just held a screwdriver against it. Well, we can't do that, obviously, all the time. So what we did was we just sat down at the computer and we designed a little belt tensioner, and we had the child machine print its own belt tensioner, bolted it onto the machine. 20 minutes later, it was working good as new. So, in fact, it incorporates a grandchild part inside the child. What it's like, really, is music file sharing, but for real stuff. Anybody who's got one of these machines can share files for it with anybody else, anywhere in the world, and then that other person can print anything that the first person can print. And as I say, we've already set up one website to allow people to do precisely that sharing. And not just plastics. At the moment, the machine works only with plastics, but I've got a research student working on adding to that range of materials. The first thing we want to do is to incorporate an electrical conductor so we can print electric circuitry as well as plastic objects, and you can see that that would take us a long way towards making all sorts of useful things. And also we're looking at depositing metals and maybe ceramics so that we can produce high temperature components, so on and so forth. Okay, let's stand back a bit and look at how the world works, and this is how I contend the world works, so this is very much open to debate. Not now, but perhaps later on in the interval. We've got various levels that constrain what people do. At the bottom level, the least significant level, the weakest level, is the level of rules. Things like, you must not eat pork, or here you must not drive faster than 30 miles an hour. Things written down on pieces of paper by one bunch of human beings in the hope, sometimes backed up by main force, that other human beings will do what they say. At the level above that is economics. Economics almost always trumps the rules. If something's illegal but it makes enough money, then chances are people will do it anyway, and you can all think of examples. Above the level economics is biology. When a 19-year-old goes out and buys a set of training shoes for £200 when he or she could have bought a perfectly good set for £40, there's no economic sense to that at all. Traditional economics says that that person's behaved very foolishly, but the person, of course, has not behaved foolishly because they're not buying training shoes, they're buying a peacock's tail. And so that's why they're prepared to spend the extra money. Biology trumps economics. And finally, there's physics. Physics is the substrate on which all of this works, and physics trumps biology. The reason why there are no perpetual motion machines that have evolved in nature is because the second law of thermodynamics says you can't have a perpetual motion machine. So no matter how hard biology tried, it'd never get there. Now, the bit of my talk is going to be split into the first three. I'm going to look at rules and then economics and then biology. I'm not going to talk about physics, though there's a lot of physics in the machine, the flow of the plastics, the forces involved and how the machine works and so on. All that detail about the physics you can find out from the project website, which I'll tell you about later on. But let's look at the first three levels of how people interact with the rest of the world and indeed with each other. Let's start with the lowest level, the rules. Well, from the perspective of this machine, the rules really are about registered and unregistered rights, things like trademarks, patents, and copyright. What is the widespread use of these machines going to mean in terms of those sorts of rules? Incidentally, for those of you who are not interested in the law, you'll see that little pictures appear on the right and towards the bottom of the slides of things made by RepRap machines. You can look at those if you don't like what I'm saying throughout the rest of the talk. The first set of rules we might be worried about are things like trademarks and what's called passing off, which is basically counterfeiting in everyday language. And that's illegal, and if people use RepRap machines to do that, then they've broken the law. If you make a Coca-Cola bottle and try and pass it off as a real thing made by the Coca-Cola company, then you've broken trademark law, and that's that. Copyright is inherent in lots of printed works and also in certain three-dimensional objects such as sculptures, but it's surprisingly restricted in this context. The files to drive the machine would be subject to copyright, but there's nothing to stop you reverse engineering something and distributing your own version of such a file. That isn't an infringement of copyright. And penultimately, patents. If you use the machine to print out something that's patented, have you broken the patent? Well, the answer is no if you do it for yourself. Patent only works, in Europe this is, I should say, it's different in other parts of the world, but in Europe, patent only impinges upon you if you're engaged in some sort of commercial activity. If you've got one of these machines for yourself and you print out something that's patented, you have not broken the law at all. And finally, registered and unregistered design. This is things like the shape of a bit of a Dyson vacuum cleaner or the shape of a bit of a Ford wing mirror. Sometimes those designs can be registered. If you print one of those out, have you broken the law in that case? Well, the answer is, again, no, under almost all circumstances. For example, there are exceptions for things like this object must fit against that object. That sort of exception allows you to go ahead and repair your own material objects, for example, even if you've got registered designs. Okay. Economics, moving on to the next level. I mentioned that the machine costs £300 of materials to get together yourself. The cheapest non-open source 3D printer currently on market is marketed by Solido Limited in Israel, and that costs £12,000. £300, £12,000. Bit of a difference. And so this is really cutting under the market. And of course, all the people who make these commercial machines, conventionally marketed, use the same strategy that you're all familiar with from Hewlett-Packard inkjet cartridges. Hewlett-Packard give you printers and then sell you ink at a rather significant markup. Similarly, the makers of 3D printers, they don't give you 3D printers, as you can see from that price tag, but they certainly sell you plastic at a markup. If you buy £20 worth of plastic to go in a commercial 3D printer, it'll probably cost you £200 or £300. £20 worth of plastic for the RepRap machine costs you £20. Finally, the sorts of things we can make. This is child shoes. These are made out of HDPE, which is the plastic they make milk bottles from. We made those in the RepRap machine. What we want to do is to design a home shredder for the machine so you can shred your own milk bottles and then make your child a pair of shoes. What's more, of course, when your child's feet grow, as children's feet so inconveniently do, you just shred the shoes again, throw in an extra milk bottle, scale the design by 1.1, and you've got a new pair of shoes. Let's move on, economics, moving now into the environment. When the RepRap machine's running, it uses about 60 watts of electricity, and that represents 8 grams of carbon per hour. So the power station is churning out 8 grams of carbon every time you're running a RepRap machine. But RepRap lays down 17 grams of carbon every hour. It lays down more carbon than it's giving off at the power station. So if we use as a source of that carbon a biological material, then every time you run the machine, you're taking carbon out of the air and locking it away in a useful object, such as this coat hook, for example. The coat hook, and indeed the child machine you saw in the previous slide a few slides back, are both made from a plastic called polylactic acid. Polylactic acid can be made virtually by anyone in a kitchen from starch by fermentation. There's one slightly tricky step to the process, which is that you have to get the lactic acid, which you make by fermentation, very, very dry. But we've succeeded in doing that using fairly cardboard box and plastic bag technology. And so if you grow your own plastic and you've got a RepRap machine, you can make stuff and you're independent of the plastics industry. And all the time you're working, you're net taking carbon out of the atmosphere and locking it away on things screwed to people's walls. All of this, of course, makes manufacturing far more like agriculture. Agriculture is the economic activity that's concerned with things that copy themselves. So it's perhaps unsurprising that that's the case. Sticking with biology, anything that copies itself, of course, will grow exponentially. If we take a typical product that you might want, a comb, as you can see, I've got less use for that than many of you. Top is one made conventionally in an injection molding machine, which is on the right, and bottom is a comb made by a RepRap machine. Injection molding machines can make 10,000 combs per hour. RepRap machine would probably take about 20 minutes to make one comb. And as I said, it takes 2 days to copy itself. Let's suppose in those 2 days that it's got enough time left just to make one pathetic little comb compared with the 10,000 an hour coming out of the injection molding machine. How many combs are we going to end up with? Well, if the RepRap machines are copying themselves after 19 days, the RepRap machines will have caught up with the injection molding machine. After a month, there's a machine for every man, woman, and child on the planet. Now, that won't happen, of course, for the same reason that we're not up to our necks in rabbits. Like everything that grows in number exponentially, it'll be stopped by resource limitations sooner or later. This is what people do when you give them access to something that copies itself. They turn those things into those things. And indeed, the reason why everybody in this room is well fed is because our ancestors did precisely that sort of activity, but with wild wheat, wild grasses, and other wild animals and plants. And that's the result of all that. It's what feeds us. RepRap's just the same. Because all the designs are available on the web, lots of people are downloading them and improving them and posting those improvements. So when you've got a machine, you can download other people's improvements, print them out, fit them to your own machine, and you've got a better machine, all for nothing. The machine actually behaves with people in much the same way as the mutualism, by popular usage, symbiosis, though that's not quite the right word, the mutualism between insects and plants, in that the RepRap machine creates goods, and people need the goods. People help the RepRap machine to reproduce. So the RepRap machine is like the flowers that make nectar. The people are like the insects that pollinate the flowers, and the goods are the equivalent of the nectar in the analogy. And that's a very stable relationship between plants and insects, and RepRap was actually designed by me to try and mimic the stability of that relationship. What about the future? Well, almost everybody in the developed world owns their own CD pressing plant, their own photographic laboratory, and their own printing press. Of course, they don't look like those things anymore. They look like an ordinary laptop computer because that's what's taken over all of those functions. Why shouldn't everybody own their own factory that makes more factories? There's the website if you're interested in having a look at the project. That's all I've got to say. Thank you very much indeed.